hello to the online audience and hello to the in-person audience, so who are often online. So anyway, thank you everybody for being here. It's worth noting that in addition to having a bacon wonderland, as probably the camera will ultimately pan around, it's also a bit of a Star Wars land is here as well, and we'll talk about that. So we're really excited to be presenting at our second Tech Field Day, this specifically around virtualization. As many of you are aware of Xangati, Xangati is a recognized leader in performance management for the virtualization sector, and we'll talk about how the solution is being leveraged both for server virtualization performance management and also VDI management. The reason that we picked these kind of two themes, I think they're complementary in nature because everything is ultimately better with bacon. Ice cream's better with bacon. I guess Star Wars is better than bacon, better with bacon. But the reason that we picked this Star Wars theme, this idea, and if you can see the sign there, where we're talking about the blame wars and the virtualization admin or the VDI admin striking back, is a theme that we developed as we dialogued with our customers, and we launched it at VMworld this past year. And it's largely because our customers are the hands-on folks like you out there in the online audience and the audience in here who are challenged with the fact that really virtualization is a cross-silo endeavor. Server, network, storage, applications all coming together in this dynamic, ever-moving, ever-evolving environment. And oftentimes there are challenges that happen out there in the world related to what's happening from a performance standpoint. And our customers, who are now in the hundreds of paying customers and in the thousands of customers who have downloaded our free software, they can effectively get their hands on our software, download it in their environment, and start to tackle and understand what's really happening in the inner dynamics and the interplay of what's going on from a VMware perspective, what's going on from a network perspective, what's going on from a storage perspective. So that idea of being able to more capably interact with and frankly more positively construct a way to interchange between the virtualization teams, the storage teams, and the network teams is in the end why customers use our software. So hence the thematic involved there. So in terms of agenda for today, we will not be dosing you and dousing you with a ton of slides. In terms of the audience, I'll introduce each of them, and then we'll go through various segments. So the first person to speak after me will be Jagan Jagannathan. Some of you guys saw Jagan present last year. Jagan is our CTO and founder. And what Jagan's going to do in his session is really talk about some of the architectural requirements that we see for performance management, specifically in the virtualization sector. So he'll do that. He'll also really talk about a lot of the rich math behind the scalable architecture we have. So that'll be the first section. The second is Nathaniel Iverson, who many of you know probably if any of you watched our YouTube channels. Nathaniel is in many ways the face of Xangati and voice of Xangati. What we're going to do is take you to a live environment, our own little marketing environment, give you guys logins and allow you to play with the solution, kind of take a hands-on tour of the product that we've set up a lot of problems for you guys to find. So we'll do that after Jagan goes to the architecture, so you have a sense of this is not just the UI, there's a lot of deep richness behind that. And we will have, certainly on hand, it's worth noting, we have a couple of our customers. We have Dwayne over here and Roger Lund as well, who are hand-on users of the product, so they could probably serve as proctors today as well, if you will. Hopefully we bribed you with some bacon.
Bribes.
None of that. After that, we'll have Steve Rogers, who many of you know as Steve888, Twitter handle. And he is we've got a little game for you guys today. Don't know how many of you, well, I know there's some Brits in here as well. So NPR has a radio game show that they call Wait, Wait, Don't Tell Me. In our case, again, going with a thematic, we have Wait, Wait, Don't Blame Me. So we have a couple scenarios of blame game scenarios that our customers have actually experienced. As we go through that, one is true, one is false. And it's worth noting that the online community, stay tuned for that because you guys can participate in that as well, and we have some prizes that Steve will talk about. After that, let's see, comes back to myself and Jagan. We'll talk a little bit about what we plan to do with this technology as we move forward. And once you guys have had your hands on it, we'd love to also solicit some feedback from you. I mean, that's why we have an audience like this on where you think this technology can go. And I think without further delay, the only other person that I wanted to introduce was Kim Barcy, who is also part of the team. You would know Kim as Xangati Press, and I think she engages and interacts with many of you virtually every day. So without further delay, Jagan, why don't you give everybody a little bit of a bio and background on yourself as well.
Okay. Mic working? Good. Hi, everyone. I know this has been a long day with lots of calorie intakes, so I'll try to keep you from not nodding off. My background, I'm an academic originally, so I was, studying until they said you can't study anymore and you have to do some other work. But I transitioned into products more with big companies like Xerox and Sun Microsystems in the 90s. Focused more on building highly scalable systems, not necessarily in the network management space, more network security, as well as in high performance computing. And then I, have been in the startup mode for the last decade or so, and Xangati is the latest adventure. What I'm going to do today is really use the whiteboard and the Sharpies. So the nice thing about Sharpies is whatever I write, I can't erase easily. So, unlike dry eraser markers. So what I wanted to do is not necessarily tell you what virtualization management is, because I think you probably know about it as much, if not more than me, but really focus on our worldview of virtualization management that drives our product and our technology. So, give you a sense of where we're coming from, what our assumptions are, what our insights are. And that way, I think when you look at the product and the demo, perhaps you can get your own insights as to why we do what we do. All right? So there's cartoons going on in parallel, and mostly Steve has done an excellent job of picking them up. I mean, it's amazing with Google Images and typing cartoons how much funny stuff there is. It's pretty impressive. So one of the things that I think a lot of us in management have always struggled with and always have come from is we pretty much have focused on management from a particular silo. So you have folks who focus on network management. You have folks who focus on physical server management. You have folks who focus on application management, which is at a little higher level abstraction. And you also have folks, even before virtualization, who focused on storage management. And really, I think what virtualization has done is it has brought together these different silos and really shed the walls that divide them. So really what that means is that any virtualization management system, performance management system particularly, has to be cross-silo. So I'm going to say that one of the first requirements we have is we have to be cross-silos. And I'm going to draw something here, which is, a simple block, which I'm going to say collect, which is the first layer of our underbelly of our architecture. So we have to collect from the network, we have to collect from the servers, we have to collect from storage, and we even have to collect from endpoints, which could be end users connecting to desktops.
Marker. That one's not working. It looks like you're ready.
Well, I think all of them are going to be.
Can you turn on the lights all the way around? Because it's really dark. Yes. Okay. It's in that corner.
Okay, let me try. I don't think I can erase this.
John, I brought some additional ones up
Oh,
from the
cool.
end of the table there.
See?
Let's try those.
Now I can see it.
Yeah. It's very defocusing. Okay, there you go. Thank you, Kim. Bacon flavored, I see.
Step on the markers.
Cross silo. It's writing very well. Either it's at the start of it or it's just running out. I don't know. So this is where we do our, if you like, what I call our alerting and profiling. And the last thing, which I mean, it's everybody talks about it, but we need to talk about it more urgently because we are taking on interactions, because we are taking on cross silo, because we are taking on live and continuous. We will have many more things to deal with in any given second. Okay, the nature of our implementation is such that we literally have maybe a microsecond to 10 microseconds to deal with each single piece of information relating to a consumption or an interaction, okay, to scale, right? So you have systems where you can have 100,000 objects going to 1 million metrics and interactions. And we come and say it's live and continuous. We can't abandon that at that point. So we have to deal with that kind of scale while not compromising any of these, right? So that's part of our architectural challenge. Just to give you an example, the demo that you're going to see is a fairly, no disrespect to Nathaniel, but it's a fairly small system, right? It has about, I think, 250 objects, the last I looked, virtual machines and physical IPs. It has about 4-5 hosts. It has about 20 data stores, if I'm not mistaken, and it has about 40 port groups, some of which were just created for just the fun of it, I think. Because, hey, I wonder how this works, and they created a port group and they never used it. And 10 of these, 10 interfaces. If you multiply each of those by anywhere from 10 to 20 is the number of consumption metrics we'll use, right? So if I have 200 objects, and I multiply it by 20, that's about 4,000 consumptions per second, right? You could argue not all 4,000 change, that we don't get information on all 4,000 metrics every second, but it turns out that about 75% of the metrics are available to us every second, okay? So this is just consumption. Go to interaction. These 200 objects can interact with any of these 200 objects themselves. They can interact with the 20 data stores I talked about. They can interact with the 40 port groups I talked about. They can interact with the 10 physical interfaces I talked about. They can interact with the 4 hosts I talked about. And while it is maybe a stretch to multiply these to calculate the number of interactions, the number of interactions is in between 200 and 200 times 4, 200 times 200, 200 times 20, 200 times 40, 200 times 10. So it's effectively potentially, in worst case, a quadratic effect. Normally, it's not quadratic enough. It's closer to something which is superlinear, right? So you have 200 objects. Like in this system, each object typically has, on average, about 2 interactions, right? So instead of 200, you have 400 interactions for these kinds of objects. Data stores typically have 10 interactions. So you have, instead of 20 data stores, you have 200 interactions. So if you do the numbers, what you end up with is you have 4,000 consumptions per second, but you have more in the order of 10,000 interactions per second. And this is a small system, right? So you're really dealing with about, let's say, 10 to 15,000 things to deal with per second. Not quite microsecond, but certainly not millisecond. So how do we do this? One of the things, I mean, I don't want to get into the details of this. How am I doing for time?
That'd be fine. I think there was, do you have a question?
Yeah, on interactions, I see you collect stuff from storage, networking, servers, and endpoints. Do you collect VMCI data? Do you collect vApp interactions that happen outside? Do you collect VIX data? Do you collect the SDK data? Because there's multiple ways I can interact with a VM that are not related to a network, they're not related to storage.
No, I understand. So what we collect is, I mean, this is not a closed system in the sense that the data that we're collecting is not sort of, well, this is it, guys. We're not going to change this anymore. So we will add to it. So it's extensible in that sense. But to answer your question, what we are interested in is a VM representing a piece of an application, its behavior.
But if I get interacted with by VIX, I could change its behavior radically.
Yeah, you can.
And if the application uses VMCI as its interconnect, you will never see network traffic, or it could use both.
No, absolutely. So you can have things which have no network traffic, and visibility of the kinds of things you're doing you have to deal with the feeds that identify whatever it is that you're doing. So if you're saying there are...
Jeez!
If there are...
That's just how
You
hard
guys
you
didn't
Yeah.
more than one might.
Well, we did set off the fire alarm at Symantec, so.
This is an example of a symptom. It's a consumptive symptom. We have to tell what the interaction is that caused
Is that
that.
an interaction right there?
There's some interaction which caused it, It could have interacted with us if it had fallen on one of us, which would have been painful. To answer your question, there are blind spots in any system, and the blind spots are defined by the coverage we get with the feeds we have. If somebody is saying we are interested in a completely different kind of information about a VM, then we have to get those feeds and accommodate those feeds. What we drive this by is we talk to our customers, we ask our customers, what kind of information they want about their world. And this is work in progress in the sense that it's an extensible set, but we expect to cover more and more as we move forward, not only in terms of new kinds of feeds, but also diversity in each.
See, I'm not even sure how you collect those, that's why I was asking.
Well,
Those ones are kind of hard to collect.
no, if they're hard to collect, we're not going to collect them, right? We can't divine it. We're not going to collect them. So if something is insulated and it's not available, we're going to be blind to it. But the point is, any management is only as good as the data it collects, the quality of data it collects, and what it does with it. So just talking about how we do this, and I'll kind of close with that, is traditional management has tended to be sort of focused on, let me get the information, let me store it. First thing I'll do is I'll store it. I don't want to lose it, and then I'll crunch the information. So it's a very data intensive, typically, not always, typically database driven analysis, right? So you can get reports, you can get visualization, but the database is a big part. The way we do it is we think of the database as something which we need to put information in for reporting, but we actually absorb this information into memory, into RAM/cache, and we crunch it, and we manage literally thousands to millions of objects organized in different ways, like trees, and pruning them and keeping them in check so that we can provide information to the UI. We can provide alarms. So every metric that comes in is checked if there's an alarm condition that it initiates, and the thresholds for both interaction and consumption is self-calculated. You can override it, but we calculate it ourselves. So when there's a recording that I think you will see, the information for recording has to be given by this collation engine. Similarly, the alerting, and so you have alerting, you have information for the UI. You also have data that you want to store in the database for reports that people want to see down the road. That data is also used in things like, if you want to get into capacity planning and stuff like that, we can use that data because it's very rich, high granularity data that we can use in a predictive way rather than retrospectively.
Can I ask, out of the 4 areas you identified that you've got
Yeah.
collect on, which one would you say you are strongest in
Um,
terms of collecting and analysing?
Well, I don't know whether I would. I'd like to rephrase that question if I may.
Sure.
So I would say that we have spent the most time of our lives with the network side of things.
Yeah, because when I first looked at Xangati, really it was just networking.
Yeah, but I think we have. I would say in the past 18 months, we really are at a place where you'll find value from our product, even if you shut off any one of these guys.
Okay.
Okay. Now, can we do a better job? Absolutely. How do we do a better job? I think a lot of it depends on the richness of information that we can get, and different environments will provide different kinds of information. Certain hypervisors will be much more forthcoming to providing information. Some hypervisors are very reluctant. Management is an afterthought in their design. I mean, nothing wrong with it, but there's just, they design it to work, and to tell others how it's working is not something that takes primacy for them.
When I first came across Xangati, VMware were using you internally in the lab environment for VMworld, specifically at VDI. I think VMware are now doing a lot of work with VC Operations Manager to add enlightens to it, so you can see view data there. Does that sort of step on your territory a little bit?
It's certainly encouraging to see them pay respect to this, live and continuous. But I think it is a very piecemeal specific thing that they're doing, which is Teradici offers APIs to give you information about PC or IP and the quality of information. So they are rendering that information. But it is not, if you look at the way we do it, it's really completely integrated into how we view everything. So it's just one more live and continuous feed, whereas I think other systems like VCOps, they still have a, fine-grained photograph to fine-grained photograph mode rather than a continuous video. That's my kind of view on that.
Okay.
Where's David?
What's that? Oh, I'm over here.
You're a blogger now?
What's that?
You're a blogger.
He's gone over to the other side.
Yeah, he said, I'm going to write about this guy.
Stuck up halfway, scruffy, criteria for a blogger.
Anything?
Well, yeah, I would, as we get into the demo, frankly, one of the things that hopefully Jagan's talked about, and you'll see this more so in the product, is, architecturally, we're to the question about VC operations, we're looking at fundamentally two different problem spaces. Our architecture really started from the performance management domain, and as you can see, some of the things that are absolutely essential on the performance side are the liveness of the system. Customers, hands-on guys like yourself would say, I need to know what's going on now. Live and continuously, I need to navigate through my infrastructure. It's worth noting, Jagan was doing some of that math, but architecturally, the system can process over 1 million metrics a second in the, multiples of that in terms of interactions, which is what Xangati does. Architecturally, vCenter operations can look at 1 million metrics over a 5-minute interval. That's kind of their architectural ceiling.
Not really.
Well, there's settings on that in the system.
No, they set the data down every 5 minutes, but they get every second of that data.
Okay, but
They don't aggregate. That's vCenter aggregates and rolls up. VCOps does not roll up anything until like a year later.
Okay. Well, in terms of, again, when you take a look at the system, what I'll say is that customers who deploy us and have looked at and actually see it as very complementary, right? Is that we're a live performance management solution that tends to be more of a longer-term trending solution. So architecturally, they were looking at predictive trends, whereas we are coming at things from a performance standpoint. I guess kind of proofs in the pudding as you take a look at things, but.
Yeah, I think the only point I'd make is I think to me it was a subtle point. Liveness is what you need to do triage. If you want to do post-mortem, you don't have to be live. And I think management systems, and this is not against any particular one or for a particular one, management systems have to get to a point where people are able to see what is going wrong as it's going wrong so that they have a chance to fix it.
Absolutely.
And if you leave it even for a few minutes later, the patient is dead. Okay? Some patients, not all patients die, but some patients die. And
Interesting analogy.
So what you end up doing is a post-mortem. Okay? And I mean, this is the challenge for performance management, whether it's Xangati or anybody else.
Well, the biggest thing is that regardless of how you look at it, it's always after the fact.
It is, but if you can save the patient, that's why I use the medical analogy, because
I mean, no matter when you look at the screen,
Yeah.
you may get alerted like 1 second after, by the time you get to look at it, it'll be a couple of minutes
Sure,
after
no,
anyway. So
sure. So that's why I brought the analogy.
We're talking about 3 minutes versus 4 minutes.
No, but this is why medical analogy is important, because there they'll tell you looking at it live is much more important than looking at it 5 minutes later.